All right. Good morning, good afternoon, good evening, depending upon wherever you are. And it is my pleasure to welcome you to another session of the YugabyteDB Friday Tech Talks. I'm Kannan, one of the co-founders at Yugabyte, and love to welcome Sergei Politov, one of the very early. Good morning, good afternoon, good evening, depending upon wherever you are. And it is. Sorry about that echo. I hope it's better now. Yeah, so it's my pleasure to welcome Sergei Politov, one of the very early engineers at Yugabyte. Would love for Sergei to introduce himself, maybe also just share like what are some of the components that he tends to work on, and then introduce the topic and take it away, Sergei, all yours.
Okay, hello, I'm Sergei. I'm working for Yugabyte for several years and working mostly on lower layer systems, the data system and the networking and distributed transactions and some backup and related features. The DB storage engine, how we store data on the lower layers. And today I want to tell you about point-in-time recovery in YugabyteDB. What the purpose of point-in-time recovery? Point-in-time recovery provides ability to restore database to state at any point in specific time window. It can be used to recover the database in case of unintended changes, such as data modification, for instance, insert, update, delete. In other words, simple data modify language parts. Table on index, create, delete, alter table, and so far and so on. So any change that could be done in database could be recovered using this feature. It provides several options to set up point-in-time recovery. It is managed using so-called snapshot schedules. And each snapshot schedule has the following options. Interval, how frequently snapshots should be created. It is required because we cannot garbage collect MVCC history after the last snapshot. So if we cannot completely clean up deleted or updated rows because of that. And it is not recommended to set this interval to very high values, because if you delete row and you don't take snapshot, for instance, for a day, the data will be, all deleted rows will still be in database for this time. I recommend to set it to 60 minutes by default, but it depends on workload. So if you have a lot of row updates or deletes, then you should do snapshots more frequently. Otherwise, if you mostly add the data and rarely delete or update that, you could increase snapshot interval. Also, there is retention option. It is how long we should keep snapshot and provide ability to recover. In other words, you will not be able to recover beyond this period. And the last option, it is database, for which we should use this snapshot schedule. It is YSQL database or YSQL database.
So maybe Sergei, if you could just clarify once what the MVCC stands for.
Okay, I will tell this.
Yeah, thank you.
How it works under the hood. As Alan said in previous Tech Talk, snapshots, we have snapshots, and snapshots are used for data recovery. Snapshot is implemented using hard links, and it will be created in milliseconds, providing minimal overhead in disk usage. Because of multi-version concurrency control in Yugabyte, it is possible to read snapshot data state at any specific time. So what does it mean? For each update or data modification, we store the time when it happened. So using that, we could read database state at any point in time. But we have to clean up this history, as I said, because if we have deletes or updates, without cleanup, they will still be in database and it will grow larger and larger. And we have these two processes, the conflicting, that we need to clean up, but we need to read entire time in the past. especially for point-in-time recovery, we should read in the bigger intervals. Also, what we need for point-in-time recovery. In order to restore deleted table is not actually deleted, but hidden from client and cleaned up after retention period. So what does it mean? If user drops the table, we still keep all the data of this table and all snapshots for this table until retention period for this snapshot schedule pass. And after that, we could delete this table with all the data, with all snapshots and the existing data. And another thing that we should be able to recover, it is Postgres system catalog. It is his types, extra data about user tables that Postgres system needs. To recover it, we use the following approach. We have because it is stored, we could have multiple databases, and each of them is stored in the same tablet in our system. So during recovery, we should recover only data related to one particular database. So how we doing it? We have the current state of this database, and we are reading state of database at the time of recovery, calculate the delta, and apply this delta to current state. And we recover just this database to state in the past. It is how it works. And here will be a small demo how it works. We'll switch to terminal. Okay, can you see it?
Yeah, maybe just to add some context, because 2 weeks back, one of the tech talks was covering the backup restore capability in Yugabyte. And now this is the point-in-time recovery capability. So just to spell out like that, what the two things are at the fundamental level. Suppose I take like a 8 p.m. backup and a 9 p.m. backup and a 10 p.m. backup. Using the basic backup recovery capability, you could restore back to the 8 p.m. state of the world, 9 p.m. state of the world, and 10 p.m. state of the world. But what point-in-time recovery additionally allows you to say is, hey, like somewhere around 8:55 p.m., I accidentally dropped a table. I want to get back to the state of the world, just before that, like 8:54 p.m. or so on. So it is, even though your snapshots were taken at 1 hour boundary, it's allowing you a finer-grained ability to go back to where you want. So I just wanted to, explain that. But yeah, thanks, Sergei. Look forward to the demo.
Yeah. Okay. So let's start with creating database for our demo. I connected the Postgres and just creating database for it. The database is created. So we could create snapshot schedule for it. We use YBadmin to manage snapshot schedules. And I'm launching the command to create snapshot schedule. That is how we invoke YBadmin. It is YBadmin. The master addresses, it is common option for all YBadmin invocations. You need to know how to contact the cluster. And I specifically know this before the demo. Here the command, create snapshot schedule. It is the interval, 5 minutes, and it is retention, 60 minutes. And it is the database name. The schedule is created, and it is the ID of the schedule. It could be used to delete this schedule, to restore this schedule. We could list all known snapshot schedules. So you could see this, the only schedule here. It is the options that I specified. And it initially creates the first snapshot of the system, this time of the snapshot and ID of the snapshot. Then let's try to do some data modification for our database. Let's create the table. It's a pretty simple table. And create index on this table. And we will try to drop this index and recover it. fill this table with some data. And let's check that out index work. It is a unique index, so we should not be able to insert the row that has duplicate value. I'm trying to insert row with duplicate value 4, and it doesn't allow us to do it. It is expected. Then let's drop the index and try to insert again. The insert succeeds. It means that index is deleted. Let's check the content of this database. So as you can see, it contains all the rows that was inserted before index drop and after index drop. Suppose this index drop was unintended, and we need to recover somehow to the state before the index was dropped. How we could do it? I'm switching to the tab with the YBadmin. First of all, let's find the time of the drop index. We have the utility command. It is ddl-log. It shows that description language commands. Not all, but all important should be here. For instance, that drop table or drop the index is put to this log, and we could see that we dropped this index, and it is time of the drop, and we could use this time to recover database. Let's restore the schedule. First of all, I need schedule ID. It will be picked from this first step, or we could just list schedules and pick the desired schedule. Then we need the time. I will use this time from the drop index. And
so you're picking up time just slightly before the drop index, sounds like, by dropping the 0.314 after that.
Yes, we are restoring to a little bit before index drop, because if I will restore to this time, it will be time after index drop.
Makes sense.
Let's check what the state of our restoration. It is command list snapshot restorations, and we will see the state that it was restored. For larger database, it will take more time, but usually it will be seconds. Then let's check the state of database. What we have here, we see that the value that was inserted after index drop is gone. Let's check where the index was recovered. And as you can see, we cannot insert the value because index is recovered and it blocks duplicate keys. That's all.
And if we do like a describe on the table like /d demo, we should be able to see the index again. No, that
it is named demo.
Just demo. Yeah.
Oh yes.
Yeah. Unique. Sergei, there was one question on the channel. The question was, I understand what retention equals 60 minutes means, but what does interval equals 5 minutes do? Maybe the...
Okay, I will explain it a bit. I will show the slide. This is here. As I said, we use snapshots for point-in-time recovery. What snapshot does? It copies, virtually copies using hard links, all the data of the database to the same disk, and also the copies system catalog. After we took this snapshot, we could apply cleanup of MVCC history. What does it mean? The snapshot interval 5 minutes. So we take snapshot, and after that we cannot, after last snapshot, we cannot clean up deleted or updated rows. So for instance, if you have one row that is frequently updated, all updates of this row will be stored in database. after the last snapshot. Then 5 minutes pass, we took new snapshot. And after that, we could clean up all deletes that was taken before this last snapshot. So we will delete them from disk. We will not delete them from snapshot, but we will delete it from actual database. And we will do it in snapshot intervals. So if you have snapshot 5 minutes, we will do it each 5 minutes. If you have snapshot 60 minutes, we will do it every 60 minutes.
Yeah, and for the demo, like one could say that we have set these values a little lower, but like Sergei was saying in the previous slide, that a good setting for the interval might be something like 60 minutes, and your retention maybe say 1 day or 2 days. So let's just say you're setting retention of 1 day and picking an interval of 60 minutes. Then roughly you have about 24 snapshots every day. And then when the 25th snapshot is taken, we are going to keep, basically you can drop the oldest snapshot. So it's like a sliding window of 24 snapshots that you're keeping. But fundamentally, any changes, if a same row changed like 100 times during those 24 hours, then yes, we cannot garbage collect that, because we want to give the ability to do a point-in-time recovery from during that any 24-hour window, right? So that's sort of the space trade-off. But it's worth noting that these snapshots themselves are lightweight. Like Sergei said, these are hard link based. So if you have a terabyte data set and maybe only gigabytes of it are changing every day, it doesn't mean that the snapshot is copying a full terabyte. These are hard link based snapshots, so they are virtual links. And the process of taking a snapshot itself is very lightweight. It's like in order of milliseconds, and it's a kind of an online operation in the system. It's not blocking. So there was a question: is each snapshot an entire copy of the database? Yes, but not a physical copy necessarily. Like if you take an off-cluster backup, then yes, it's a physical copy. But these snapshots are in cluster and they are link-based. So think of it as virtual copies of the entire database. There was another question: how does a user navigate to a prior point in time? I presume you'll be giving a demo. So yeah, you did describe that in the demo. I hope that question was answered.
So when we do restore snapshot schedule, we specify time at which we should restore. It is just local time for the user. Also, you could specify the time from now. Here, I don't remember how to help. Okay, I think it should be without arguments. So you could put there is restore snapshot schedule, and you could put minus interval, for instance, minus 1 hour. It will recover to 1 hour back. If you don't know the exact time, but you understand that it happened nearly 1 hour ago, you could do this way.
I think one other point worth mentioning is all of these are part of the open source YugabyteDB offering the ability to do backup, restore, point-in-time recovery. So this is all in the Apache licensed open source code of YugabyteDB. Are there any more questions? I think Frank is typing a question, but I only see half of it. It says, I like the demo idea. Typical user error, we need PITR for, but it doesn't look like a completed question. So we'll give it a minute. Meanwhile, I wanted to also mention that the next week's Friday Tech Talk topic is on 2 index related features. One is partial indexing. The other one is expression-based or function-based indexing. So would love for folks to join us next week as well. And but I think there aren't any more questions for today. We can wrap up. Thank you very much, Sergei, for today's presentation, and look forward to seeing you all next week.
Thanks you all for attending.
All right. Have a good day.
Thanks.